self-worth being in grades and performance and things like that. And he's like, that's like what the Pharisees did, was that they put their worth and perform and everything like in how well they kept the law of Moses and how strict they were with it. But that's not really what it's about. It's just about learning and becoming better little by little. And I thought that was really interesting.
Thank you. Okay, we're gonna get started. Ashley is gonna say something for us. Thanks.
Dear Heavenly Father, we are so grateful for being for this beautiful day out. We are so grateful to hear at BYU and to be learning how to be better teachers like their son. And we're grateful for our many blessings, and we pray that will help us to learn and to grow as a class and to think of ways that we can reach those students. Father, we're grateful for Ms. Hampson and the effort she put into this lesson, and we say these things in Jesus Christ. Amen.
Amen. Thanks very much. Okay. We were brainstorming spiritual thoughts for those that came in just right at the beginning, or right at the end here, because I didn't have one totally prepared. But I normally like to prepare one, but today I forgot. I need to remember. But these are the two things that I was thinking about recently in my scriptures, because I started to really look Mormon again, like at the beginning of the year. So I'm in 1 Nephi still, but sort of near the end of 1 Nephi, thankfully. I'm not failing completely at my scripture study goals. One thing I remember is actually in the very first verse, 1 Nephi 1:1. Does anyone know that verse by heart? By chance?
I haven't been born of
Goodly parents.
Having been taught somewhat in the learning of my father. No.
It's something I'm sure better like
I'm gonna pull it up because I want to get the right words. So it was the thing that struck me about it. So he says, I, Nephi, having been born of goodly parents, therefore I was taught somewhat in all the learning of my father, and having seen many afflictions in the course of my days, nevertheless, having been highly favored of the Lord in all my days, yea, having had a great knowledge of the goodness and the mysteries of God, therefore I make a record of my proceedings in my days. And for whatever reason, when I read this, I don't think I've ever noticed it before, because I was goodly parents, skip to the next verse, I think probably, when I was reading, you know what I mean? And he says, first, having seen many afflictions in the course of my days, and then he says, nevertheless, having been highly favored of the Lord in all my days. And I thought it was really interesting that he sort of put these two right next to each other, right? First, to say that maybe both of those things can exist at the same time. You could be both afflicted and highly favored of the Lord. And second, I think it tells us a little bit about Nephi's sort of character and his optimism. There's the other verses later where they're and we ate raw meat, but our women and children were healthy. And do you know what I'm saying? He has this kind of spin things in the most positive light attitude. Have you noticed this about Nephi? Mm-hmm. I feel like if it were me, I might have been murmuring. Anyway, so I really like that he puts these two things together, this idea of sort of affliction and then also being highly favored of the Lord, being blessed of the Lord, and how a shift in our attitude about things can make a big difference in the way that we perceive them. So Max Planck has a quote. You know who Max Planck is? Yeah, Planck's constant, or Planck's constant. We're pronouncing it in the German. And he has this quote that he said, and he says, when you change the way you look at things, the things you look at change. Right? And so he was talking about quantum mechanics and if you're measuring something, you've altered the system. Do you know what I'm talking about here? So you can't really know what it was before you measured it and whatever. So he was talking about that. Basically, the actual character of the system changes when you change the way that you're looking at it. And I think that that's true. When you change the way you look at things, the things you look at change, meaning the substance of what you observe is different. Does that make sense? What do you guys think about this in the context of being, for example, a first-year high school teacher? Yes.
I think all of us kind of have like these ideals of what we want to be as a teacher. Like we sit in these education classes and learn, I'm going to do that, I'm going to do that, and this is a super cool idea. And I think we go into our first year like kind of envisioning something, but we're probably going to get there, and it's definitely probably not going to be our ideal. And so like we have to remember like when we're in the midst of that, to remember to change how we look at things. Because like it's hard to do now, like change how our ideal looks because we're not there. We don't know actually how it's going to be.
Uh-huh.
So we have to remember when we get there to change how we look at things so that we can have a better idea and be happy with what's going on.
Yeah. Like finding satisfaction in your work and being happy is really important as a teacher because it's common for teachers to get really burned out. And that's especially true for new teachers because it's overwhelming, right? There's so much that you have to do all of a sudden that you didn't even, there's stuff that you have to do as a teacher that you don't even know that you have to do it until you're like standing in front of a class and you're like, aha, this is the moment when I have to make an evil stare. That happened to me. And then my students laughed at me. I clearly haven't practiced this skill, okay? What else do you think? Yeah.
I just think like that keeping perspective is important because I think that your students can pick up like on your attitude. I went and observed a class one time and like the teacher just got up there and just like me. It's just like chemistry. I'm just teaching, like trying to get through the day. And like some of the students would come and sit back by me, and I'm not saying I'm amazing or anything because half the stuff I taught them was like wrong accidentally, so that was like really embarrassing. But like whenever I was like teaching them something, I was just like really real with them, and I was like, look, this stuff is hard, and you're probably not going to get it. So, and I don't really understand it sometimes. So like, sorry if this is confusing. And they were like, but you actually, they were just like, he doesn't care about what he's teaching, and so they're like, we don't really want to be here either.
Mm-hmm.
And I just think that like when you maintain that perspective, like, hey, I'm here and I'm going to do this, and I'm going to have fun, and like, let's just like make it work even if it's hard. But like your students pick up on like your energy and things like that, and it makes your classroom a more positive environment as well.
Yeah, I think energy and like enthusiasm are super important. And I think also just like having a sense that like your life is okay and you've made a good career choice, even when it doesn't like sort of feel like it's a good choice. You know what I mean? Like when things are really hard. There's a couple of things that I think are helpful. So like one thing to do is just keep a journal for your first year, and like at the end of the day, always write down like, here are 3 things that went well today. And like maybe here's one thing that I want to think about doing better next time. And just kind of like have an intention about recognizing the good that you're doing and where you have achieved your goals or where something good happened with a student. And another thing that I think is nice is periodically, and some people do this like once a week, but just send home a note to a parent to tell them something good about their kid. Because usually if parents are ever receiving a communication from the school, it's like their kid is suspended or in trouble or something terrible is happening. And so like taking a minute to just recognize like, wow, Joey did such a good job working with his lab partner this week, and I know that's been a struggle for him in the past, but this week he did a great job, And I think that small things like that help to maintain your perspective, and like having a positive attitude is really important like for your sanity, So, okay, good. We'll go ahead and get started. We said that we were going to look at the chemical concepts inventory again. Do you guys have that? So we'll pull out and we'll look at maybe the second page. Okay, question 5. D, good. How do you know?
Well, it definitely doesn't.
Because E is like not visible on a page.
I do not.
Well, I just looked for the ones that had the actual SO3 molecules, and then I knew there were some leftovers, so I saw that there was some extra sulfur. So
Yeah.
all the oxygen.
Good, so looking for SO3, right? So 1 square and 3 circles to represent the actual molecule that's formed is important. And then making sure that you've taken into account the eliminating reactant. Yeah, so D is the correct answer. What do you think kids would be likely to do? C, why?
Because they aren't counting, or they're not taking into account like limiting factors or anything.
They just look at the equation and they're like, SO3, that looks like SO3, awesome. Uh-huh.
I also thought they might choose B, because they might look at like 2
Oh.
sulfurs with 6 oxygens on it.
Uh-huh, like 2 SO3
I
as
also
one.
put A, because I did it at 3 o'clock in the morning. And I didn't realize that the 2 was
Oh,
like
like
two of them.
2S, with like
Yeah.
S2.
Yeah.
Yeah.
So
Uh-huh.
that's like real life mistakes happening right there.
Yeah. Kylie did a lot of things at 5 o'clock this morning, so. Okay, yeah, so interesting. Isn't that interesting though also how sort of a simple question could tell you a lot about like, oh, my students don't understand the difference between coefficients and subscripts. Or my students understand the coefficients and subscripts, but they didn't understand limiting reactants, right? So that's why stuff like this can be useful. Okay, what about number 6? Uh-huh, yeah, good. So E would be like the gas phase, right? What do you think is a common misconception for people? D or A? Or B, maybe some of the molecules are sort of breaking apart and that's why it's becoming a gas. So all of those are sort of getting at this misconception of the molecule breaking apart instead of the molecules separating from each other, right? So intra versus intermolecular forces. I think, let's do one more. What do you think?
Yeah.
True or false? When a match burns, some matter is destroyed.
False.
False. Yeah, and we talked about this actually in class, right? The other day. But even though it looks like some matter isn't there anymore, it goes into the gas phase, right? So this idea that we can't necessarily see it with our bare eyes, unaided eyes. Okay. What's the reason for your answer to question number 7? D is the correct answer, right? So there's a chemical reaction, the atoms are not destroyed, they're only rearranged. What do you think would be most common student responses?
C.
Oh wait, I heard 3. What did you say over here? E?
Actually,
You said E. Tell me, Scott.
if you like, you'll see if the match burns, they'll turn to ash, and if you wait before and after, you easily see that, oh, there's less mass, it was destroyed.
Uh-huh, okay, good. And I heard someone...
I said B, just if the matter is consumed by the flame, they'll see like the flame is burning the match and you'll see that the ash is less.
Uh-huh, okay. So the flame does something to like eat up the matter. Sure, that makes sense.
Because C is kind of
And I figured the same concept, that they would consider that even if you include all the ash that fell off the match, it's still less than that. They don't consider the gases things.
Good. So the misconceptions here are generally just about conservation of matter, right? They're all about different things that students might think about conservation of matter. Okay, let's stop that. Done with that. We'll come back to it again. Just keep it in your notebook and we'll come back again to the other items later. Okay. First of all, I have a couple of announcements. USTA is paid for, and the 5 people, Kylie, Amber, Emma, Kevin, and Ammon, you are registered. So you just have to show up. You also have a 1-year membership to the Utah Science Teachers
Are you serious?
Association. Yes. Thrown in with your registration for the conference. Congratulations. Number 2, next Thursday is the day that we're going to do the science fair at Mountain View. Who can remind me who is committed to doing that? It was like 5 or 6 of us, and I think we told her we would have 6 people. Okay, so are you not certain?
I have to get work off first.
Okay,
but,
do you think you can?
I think I can.
Okay.
I will try.
Okay, I think we told her we were gonna have 6 people, so I'd like to do that if we can. Just to make sure that there's enough judges, because they have a lot of kids that need judging, and I think we may be the only judges.
I can bring my husband.
Is he a science major?
No, but he's really building, savvy, techie.
So you feel like he could do it?
Yeah, he's
Okay.
Is that the 31st?
Huh?
Is that the 31st?
The 31st, yep, and we're supposed to be there at 5:15, and they will feed us dinner. and train us on how to use the rubric, and then we'll go do all of the stuff. And then I think we'll be home by like 8.
I can probably skip my class at that time.
Good, if you can, then come. Yeah,
Brilliant.
I can't make it.
you can't?
Yeah.
Okay, then you should skip your
I
class.
will skip my class.
Don't say anyone that I said you to do that, okay? That
I
was
will.
bad language, but you should.
I
Okay.
told someone that said something earlier. I told them to set.
Are you making fun of me?
No, I did the same thing earlier today.
Oh, okay. I was like, I don't like that. Okay,
Well, I'm being made fun of.
okay, so January 31st, we're okay with that, and I sent you an email. If you can't come on the 31st, there's a couple of other science fairs that are available, and there will be some more that are coming up. It is an assignment. I don't know whether I told you this. Like, you have to go to a science fair somewhere and be a judge. So there's a couple other that are coming up, and I think they're at elementary schools. And then there's the one at BYU, and I don't have any more information about that, but when I have more information, I'll get that to you if you want to do that one. Okay, now, let's talk about what we learned from our reading. I'd like to make a list because all of you guys came up with different things. So I'd like to make a list of the things that you learned. Who wants to share something they learned?
That the standards are meant to like help you progress as a teacher, like over the course of your time teaching.
Okay, so learning objectives are going to help the teacher. How?
It just said like, I think, I don't know, like as you teach, like you can like adjust what you need, like based on your learning objectives, like it helps you identify clear goals for your students, and like if they're not meeting those goals one year, like it makes it easier to adjust for another year or further
Sure.
instruction or something.
Good, okay, so understanding how students are doing on these learning objectives can help you adjust your instruction. Good, what else? Yes.
I learned about Bloom's taxonomy
Yeah.
of hierarchy of thinking methods.
We just call it Bloom's taxonomy normally.
Brilliant.
Who else, this was like the first time you saw Bloom's. Was anyone else, this is the first time you ever heard of Bloom's taxonomy?
We've gone through so many lists in Dwayne's class.
Okay. Who else has seen Bloom's taxonomy before? Okay, you've seen it before. Was there anything new or different that you learned about it this time?
Not different, but I liked that they like had examples of, okay, here's how it would apply to a learning objective.
Uh-huh, yeah. Okay, so like more concrete because you can
Yeah.
see, how do I actually use this? Yeah. We're going to talk about, later today we have some time to look at a website it's like it's a learning objective writer. So you like type in stuff and it like, anyway, it doesn't really work super well, but the thing that it does have is you can say, I want one that's an evaluate Bloom's taxonomy, and then it'll give you like a bunch of verbs to choose from that are related to that. So it's useful that way. It's not really useful as like a method for actually like writing, I don't know, you know what I'm saying? But it helps you sort of brainstorm. So we'll talk about that. Good, what else did we learn?
Yes. This wasn't like specifically in it, but I kind of made a connection that it seems like the learning objectives, at least writing them this way, is more about teaching the students to apply what they know, not just to know things.
Okay, so I think that's kind of related to like Bloom's taxonomy, so like sort of going for like higher order thinking. And a lot of you guys had questions about, you know, how does that work? What's the balance? Do you always have like lower order first and then higher order? And so we'll talk about that in a minute. Other things that you guys learned? Yes.
I learned that there's different categories of learning objectives.
Uh-huh, okay.
There were cognitive, psychomotor, and attitudinal.
Oh, this is gonna be hard. Okay, psychomotor. And then sometimes we call these affective or attitudinal, the same thing. Good. So different kinds of objectives that we can have. Affective is like people, for example, feeling like they like science, or people feeling like they hate science. That's like an affective domain. Okay, good. What else? Two more things.
This is like something I learned, but also a question.
Uh-huh.
So kind of going along with like learning objectives helping the teacher, it also said that it makes it easy for you to like communicate what you're learning in your classroom to other teachers. So I learned that that's a thing, but is that something that actually happens? Like the principal comes in and is like, hi, submit all of your stuff for the entire year of what you're learning, and you're like, oh, okay.
It depends where you are. Yeah. Did you guys, by the way, I wrote about this in my response to your thing. Do you guys see the feedback that I gave you? Do you guys know where that is?
Yes.
Yeah, I respond to everything that you write.
Really? I know where to find it, just didn't know.
If you just go look at it on Learning Suite, like if you pull up the assignment, there should be like,
Well, now I know where it is anyway.
yeah, so I write everything that you guys submit, I'm always gonna write feedback there. And it's gonna be important, especially when you have like your lesson plans and the objectives that you submitted today, like I'll write some feedback there for you. Does that make sense? And so you'll want to make sure that you look at that. But I also always respond to the things that you say. You guys always have interesting thoughts and questions. So what's another thing that it's not on our list so far, but it's really important about learning objectives? Like, what are they for? Yes.
They're focused on the students instead of on the teacher. Like, I don't know, I feel like earlier we were talking about like, what should you as a teacher be doing for the students, but this is like, what are the students going to be doing to help facilitate their learning?
Good. So it's student-centered in the sense that they're always written in terms of what students will do, right? But also student-centered in the sense that we use them to communicate with students what's important, right? This is what we want you to be able to do. So we help set the learning goal. And that's like one of the most important things. There's another really important thing that should be true about learning objectives. They're related to what other thing? Yeah, they're related to assessment, okay? So, if you remember, we talked last time about backwards design or understanding by design. Do you guys remember that? How does that work? What's the first thing that you're supposed to do? Standards, which you turn into learning objectives, which tell us what students should be able to do. And then we ask ourselves, how will we know? Which is assessment, right? So the learning objectives are tightly connected with assessment in that way. And then after we do all those things, that's when we think about, okay, what do we do in class? Okay, some important questions. One that many people asked, at least 3 people asked about Bloom's taxonomy and the different levels. So I should tell you, the Bloom's taxonomy that was in here is like an older version, and there's a revised version, and it has create at the top instead of evaluate. So it's like evaluate is below create. So just keep that in mind. Sometimes it's actually helpful to have students create something. So for example, instead of having a diagram that they label, you might ask them to draw a diagram, and that's them creating something. Okay, okay, low level Bloom's taxonomy, 2 kinds. What are they?
Knowledge.
Remembering or knowledge, and comprehension or understanding, okay? So like remembering and understanding are like the lowest level. The vast majority of tests that you think about, like multiple choice tests, are like remembering and understanding, right? The other ones we call higher order. So there's application, and then
Or am I skipping one?
there's one in between. Analysis, analyze, synthesis, evaluate, and create, right? And those are, so I think now they would say like application, and then analysis, and then evaluate or create. I think that's how they do it now. I don't remember exactly. What's an example of like application? This is actually when application is easy to do in chemistry. What's an example?
Wouldn't that be like a lab?
It could be a lab that you're doing, like you learn about some principle and then you're gonna do it in the lab. Sure, what else? On a test, can you do it?
You could ask them, where would we see such and such principle in real life?
Okay, so like we learned about this principle, tell me about how this happens in real life. Also, like anytime that you ask them to look at some, the temperature was this and the pressure was this and like what's gonna happen to the balloon when blah, blah, blah. You're asking them to apply the principle to a different situation that they haven't seen before, right? So anytime you have like a problem in chemistry, it's usually application. Good. What's an example of analysis? Yeah.
Maybe like we talked about last week, the different models of an atom, you could have them analyze like the benefits of each model or what we learned
Or
from each.
comparing and contrasting.
Yeah.
I think that in the thing it said compare and contrast was evaluate. Somebody said that in their comments. I don't think that's true. I think compare and contrast is analyze. Yes, what do you think?
If you have like a set of data and they have to look at the data and make an
Uh-huh.
analysis of the data.
Identify patterns in the data, that's analyzing the data, good. And then evaluation. Evaluation means you're making a judgment about something, how good it is, right? So like what's an example of something where we might ask people to do something like that in chemistry? Yeah.
One of the teachers I observed did like it was like a progressive lab, and they took like little Cheeto balls and they like had to she would like write on a worksheet like a specific molecule, and then they had like the different, I can't remember like what the word is, but like the shapes of them.
Yeah.
And they had to like demonstrate it with the little thing, and then she would come over and they had to like approve it with her, and she like signed off.
Okay, so she was evaluating their work.
Mm-hmm.
Okay, what's something that we can ask the students to do that's an evaluation?
I wonder, I don't know if this counts, but if we gave them kind of like a problem to solve and then like a set of materials and like no directions, but just like they had to evaluate the best way to solve that chemical problem.
That's like definitely problem solving.
Yeah.
It might be more like synthesis if they were taking these things and kind of figuring out how to work it together. We actually do evaluation whenever we ask students to rank things. So like, let's say you're ranking these molecules by the strength of their intermolecular forces. Then you're making a judgment about which one will be the highest compared to the others. So that's an evaluation sort of task. Another thing that I've seen is people will give students a problem that's wrong or an explanation that's wrong. Is that what you were gonna say?
Yeah, I was gonna say, I've seen examples where like, it goes like step by step, like so-and-so did this for their problem, like there's a step somewhere that's wrong and these the wrong answer, and like they have to look at all the steps and find where the fictional student
Where's
went
the
wrong.
mistake and like what would you do differently, right? So stuff like that can be evaluation. Now what about balance? What do you guys think about that? Should we always be shooting for higher order? Should we always be shooting for lower order? Amit.
No.
Okay, can you elaborate please?
I think we should have some balance. I feel like there's things that are important to learn at the lower order as well as at the higher order. Higher order is often better for engagement and retention, but it's a lot more complicated to build, so it's hard to do that. That's one of my questions, so.
Yeah. So is it good to have higher order things for students to work on? Yes. And I think if you think about the science and engineering practices that we've talked about, like designing an experiment is like sort of a synthesis level, right? Analyzing data is analysis, right? So there's like, if we're targeting those science and engineering practices, we're naturally going to be targeting sort of higher levels in Bloom's taxonomy. Should you always, every day, be doing that? What do you think? Or do you have a comment, Emma?
Could this be like a good way to use differentiated learning? Like some students may be at the lower level and you can be building them up to the higher level, but some students will be starting at the higher order and working up there. Is that like a way to facilitate differentiated learning?
Yeah, I feel like you could do something like that. I always worry about differentiated instruction not being equitable. You know what I'm saying? So like I don't want to have kids, for example, you can imagine if everyone did that, then some kids might come into school and just all be doing remembering, understanding, and it's like what do they call it? Like, in one ear and out the other, like regurgitating on the exam, all of that stuff. Do you know what I'm saying?
Yeah.
Like, and then forgetting it promptly. So like some students,
Because they get stuck in that.
they would get stuck down there, right? And then they wouldn't have the opportunity. So I feel like it's important to provide the opportunities to all of your students. But yeah, it's one way that you could potentially differentiate sometimes, I think. Yeah.
I mean, with it, like, I was thinking of it in the sense, like, there is some information, it's like you, for example, are like explaining a formula.
Mm-hmm.
Like for, I don't even know what, something, or like how to balance an equation or whatever. It's like, there is some level of just like, hi, here's how you do this.
Mm-hmm.
But then from there, it's like you can build and provide activities and experiences for them to like say like, look, this is where you might use it in real life, or try this on your own, or before your lab, you need to balance this equation, and then
Yeah.
you can see how this reaction works, or so, like, I don't know, that's how
Yeah.
I like pictured it happening. If it's realistic, I have no idea, but.
No, I think that that's reasonable. And one of you guys, I don't remember who, it might have been like Amanda. What's her last name, Amanda? I think that you were one among the first people that submitted your thing. Did you ask something about this? Maybe?
I think so.
It was someone early on so I graded some yesterday and some today. So some people weren't doing it at 5 a.m. They did it like a day in advance, which was like super nice. It's okay. But anyway, I said most exams. So like here at BYU, I would say in a Chem 105 exam, it's probably like 40% lower level and 60% higher level thinking on an exam. In a high school classroom, it might skew more towards sort of the basics of like understanding, but you at least want to shoot for understanding as opposed to remembering. Does that make sense? So it's not just like, I remember that word, I will write it down, or, you know, but you have to understand something about it to answer the question. But that's probably 60%, and then maybe 40% are like higher order, you know? It depends also what topic you're teaching and stuff like that, yeah.
How much of, I mean, nobody may be able to answer this, but like how much of like measuring our students' understanding and like the Bloom's taxonomy has to be from tests?
Yeah.
Like, could you like have a unit where maybe you didn't have a test but gave them some other kind of assessment where maybe they just did a lab instead, but that was like, it was like a more advanced lab? Like, I don't know
Sure,
what
yeah.
schools like require of you or like expect.
I think it would vary depending on the school that you're at. But I would say it's pretty normal to have a test for each unit of instruction, which if you were looking at like textbook chapters might be like 3 textbook chapters or something. Maybe you have like quizzes at the end of each chapter and then like a test that's after 3 chapters or something like that. But that doesn't mean that the test should be your only form of assessment. So like labs can be really powerful, especially when you're looking at some of the science and engineering practices, right? Because students have to use them in the labs. And then there's things like presentations. You can have like a rubric that you use to monitor student conversations during class. And maybe during that unit, you're going to be monitoring group conversations and just taking notes on them, and you'll give them a rubric score at the end to demonstrate their ability to communicate information, like one of the science and engineering practices, right? So I think that there's a variety of ways that you can do assessment. It doesn't always have to be a test. I think it commonly is. Was that your experience in school, generally? Yeah. I think it's important, so what I tried to do each quarter during the high school year, there would be maybe like 2 or 3 exams, like tests, and then I would try to make sure that each quarter there was some sort of like alternative assessment. So a presentation, or a poster that they had to make, or you know what I mean, something that was just different that wasn't the same as the exam, so that for students who maybe aren't good at test taking, there would be some opportunity for them to like demonstrate their knowledge in a different way. And I would usually put those things in the category of exams. Yeah. Okay. Some of you guys asked about also the way that we use objectives to talk to other teachers. So Kylie asked about this, and I think there was someone else too that mentioned this. Anyone? No? Okay. Well, Kylie, this is what I think about using objectives to communicate with other teachers. I think it depends very much where you are. I know that there are schools where principals require you to submit lesson plans with specific learning objectives every week. And that's like part of your job and you have to do it. And so there are places like that. In my school here in Utah, we basically like had a dysfunctional chemistry department because the other people were like really mean. They were really mean. They wouldn't let me use the lab. Like I couldn't use the lab space.
That's mean.
I know, and I was like, okay, that makes things challenging. Anyway, we figured it out, we worked around it, but they were like really difficult people. Anyway, so we didn't really communicate about student learning at all. In Massachusetts, in my school in Massachusetts, we actually had like 1 year, we did this big like alignment for the like regular chemistry and the honors chemistry, and we looked at all of the learning objectives and like what level we were going to assess them at in regular chemistry versus honors chemistry. So like for example, with chemical equilibrium, in regular chemistry, we would expect them to have a qualitative understanding, like to explain Le Chatelier's principle, or like at equilibrium, you know, the forward and reverse reaction rates are occurring at the same rate. Do you know what I'm saying? But in honors chemistry, they might have to like substitute values into an expression to calculate an equilibrium constant or something like that, right? And so we actually went through the whole curriculum and established all of those and agreed on them. Part of the reason why we did that is because the teachers had like really different philosophies about how to teach. And so the department chair thought it was important that we establish clear learning objectives, and then we had freedom to teach it however we wanted to teach it, as long as we were like reaching those learning objectives. Yeah. Any other thoughts about our reading? What do you think? Okay.
I really liked how they gave examples
Uh-huh.
of the things. I thought that was really helpful, just to illustrate for us, like, just tell us what we need to do.
Yeah, and I think one of the things that's especially useful about the examples is actually the level of specificity, and a couple of you guys asked about that as well. Like, is this specific enough? Like, how do I know that I've written a good learning objective? And you want it to be like specific enough that a student could look at it and like know what they needed to do. And that's kind of a vague description, and I think by looking at examples is how you kind of figure that out. So does everyone have their learning objectives that they wrote? You have them available? Okay, because I made a learning objectives feedback form. Another person asked about how many learning objectives we should have. Usually it's like 1 or 2 per class day. So if you have 3 standards that you're working with, you might have between 10 and 15 specific learning objectives. That would be sort of the expectation. Does that make sense?
Okay, so the way I have it written is kind of like a couple of different in the same like paragraph kind of thing. Should I separate those so they're more clear?
It might be helpful for whoever's looking at it. So I'll pass these around. You should take 2. So on this feedback form, there's a bunch of different things, right? Each one of these little guys is like for one learning objective and then for another learning objective. Are you with me here? Okay, and there's 4 criteria that I put on here. Okay, how do we decide if it's a good learning objective? Number 1, does it describe an observable student behavior? So it shouldn't be about knowing or understanding because you can't observe those things. Are you with me here? It has to be something that's observable. It has to be a student behavior, not the teacher's behavior. You should have, each of you should have 2 pages, 2 copies of it. Okay. Number 2, does it use an appropriate and descriptive action verb? Okay. And we might include, as you're looking at the whole, the set of learning objectives, is there a variety of different things? So for example, if every learning objective says that students should be able to describe, then like that's not ideal because then it's just like one thing that they're gonna do. Do you know what I mean? Yes.
So, sorry, this is like backtracking, but with the standards, like how many class periods should you get out of the standard? Like,
We decided last time like 4-ish, right?
so then if you're supposed to, so we should have like 8 learning objectives per standard, like potentially minimum. Like if we're supposed to like.
Between 4 and 8, yeah. So if you have 2 to 3 objectives, that's why I said like maybe 10 to 15 standards would be normal. Does that make
Is that
sense?
flipped? There's 3 standards, we should have 10 to 15 objectives?
Yes.
Oh,
Did I say the wrong thing?
yeah.
Yeah, that's what I meant. Yeah, she's like, what? We have to do 15 standards? That's the whole core. Yeah, so for each of the standards, you might have between like 4 and 8. That would be like a normal amount to have of specific learning objectives.
Because then within those objectives, like could you potentially work on one objective for like 2 classes?
Yes, and you can also potentially work on one objective for 2 or 3 or 4 class periods. That's fine.
So like it just depends on the standard though and like what,
Mhm.
okay.
Yeah, so part of what you're going to be doing now, you're going to give some feedback to your peers, to 2 peers, and you're going to be evaluating each of their objectives based on these standards here. And then also at the end, there's evaluating this set of learning objectives. So like, do we have a variety of levels in Bloom's taxonomy? Are we including the 3 dimensions of the next generation science standards? Does that make sense? And then another thing that you could give feedback on at the end is like, do you think that they've captured like everything that a student would need like leading up to the performance expectation, which is the standard? Does that make sense? As an example, one of the standards is about rates of reaction. And it says that you need to know, or that you, what does it say? Provide an explanation, I think is the one it is, but like, so explain why rates of reaction vary with temperature, pressure, or concentration, right? So like, how do they know about concentration? What do they know about concentration? What do they know about temperature? Right? So that's like embedded within the standard. You're gonna probably have to like instruct them about those things, right? So you might have specific learning objectives. Does that make sense? Okay. Okay, let's go back. We have 4 things. Each objective, we're gonna test it. Number 1, is it an observable student behavior? Number 2, is are we using an appropriate and descriptive action verb? Number 3, are we providing enough detail to be clear about expectations? That's obviously subjective, but like, for example, if you had a thing that was like compare and contrast models of the atom, that would not be specific enough because you'd want to include like Dalton's model, the plum pudding model, the Rutherford model, and the quantum mechanical model, or something like that, right? You want to list, these are the models that you're responsible for. Okay, and then the last one is including performance targets when needed. I don't know that we necessarily like have those, but that was like a thing they talked about in the reading. So for example, you might want 70% accuracy on your spelling test or something like that. So maybe you have something like, the only thing that I can think of would be like if somebody had to like, memorize the names of the elements or something, and maybe you let them have 70% accuracy. I don't know. I'm just making something up. So that last one, I don't know whether it's gonna like really apply, but the first 3 for sure need to apply. Do you agree? Is this everything that we need to assess the objective, or are there other things that we should also think about? Because I made this myself, so I might not have thought of everything. Do you think that these criteria are enough to assess the learning objectives?
I think so.
Yeah.
It's enough to improve it for sure.
Okay,
Maybe
now.
that it's related to the standard? How related is it?
Oh, yeah, related to the standard. And so I left that, I think, sort of in the general category of like suggestions for improvement, How related is it to the standard, or and also, do you have enough learning objectives, or are there holes? like, oh, you're missing this concept and you need to talk about that concept, okay? Okay, what is our learning objective for this activity? Students will be able to, I'm gonna write SWBOT.
Evaluate.
Learning objectives.
Learning objectives.
And
How?
create. No, just kidding, we're not creating.
let's
We
give
created
it-
last time, okay.
We're gonna be giving standards for the evaluation because we wanna be specific. So evaluate learning objectives based on, we could say the rubric, but we could list the things here. So like student-centeredness, appropriate verbs, let's say. And then clarity or specificity. Do we like it? Okay, good. So now you have your learning objectives and you have 2 papers. It is your job. I think it might take 10, 15 minutes to look at somebody else's. Do you agree?
If I accidentally did like one for each standard, you know.
Then the people who do your evaluation are gonna have lots of feedback,
Okay.
right? Because they'll be like, oh, you need these other things, right? So that's good. Let's try 10 minutes. Everyone basically has to like just switch with someone else, except we'll need one group of 3 to go like, ding.
Everybody to the left.
Everybody pass your computer to the left, is that what's happening? That seems like a little, okay, I'm good with that. I'll take yours over to the other side.
Did we also get more papers? Because I didn't realize that it was one.
Do we have
So, yeah,
extras?
mine's
There's
extra. I
extras.
kinda just
Yeah,
wrote
here.
them on
Here you
this
go.
paper, I only wrote down each because I did.
So does everyone understand the task here?
Almost, yes.
Does everyone understand the task?
Yes.
Okay, good.
Is the 3 is this backside?
That's the
Do you want me to
best.
like sit back there?
It might be easier.
Yeah, so, and you can start.
It was on, but it's been on all day.
Oh, that's the best. Yeah, I thought I had my quota thing. I like remember like circling it up and like. putting it-
So let's take about 10 minutes. So by the top of the hour here, we should be done with this first evaluation.
Oh, my God.
How are you guys doing?
It's been dead.
is dead.
It was on.
So you have to
it's
plug it
been
in?
dead. Yeah. It's
Okay,
turning on.
that's okay. And do you have ones to evaluate?
I-
Oh, these ones, okay,
Do you
good.
want me to evaluate those? I don't know.
It's okay.
I'll
His
Which one?
computer's back on, like, right now.
Okay.
So he'll be okay.
If mine don't.
We can trade cards back and forth.
Okay, so those are like the standards.
I'm just saying, I didn't know what I was thinking.
That's- What do you think about the first one? Recognizing? Yeah, so what do you think would be better?
Oh no.
Okay, so they could be, so recognizing, it could be like recognizing, or like in a diagram at the molecular level or something like that. Or it could be explaining, or it could be, making a model. Yeah. Right? So those are all possibilities. I don't think I understand what it means.
So like gravitational potential energy has like the least entropy compared to like thermal energy. And like correctors, and that's like it's like chemical energy, nuclear energy, and efficient or not.
You kind of need to know the standard too, right?
What?
Kind of need to know the standard.
I don't know.
I've never thought about that. Did you do
I went
that?
to uni, so.
In what class?
Physical science.
Interesting.
And it's like the easiest way for me to understand efficiency.
Yeah, because the degree of energy is basically becoming usable energy.
Right, exactly.
Huh. That's like an advanced concept for high school. That's kind of how I feel. But, so what do you think? If it's about comparing the energy to nuclear versus chemical.
Sorry.
I
What
would
are we
like,
gonna do?
like, I don't know, the ways I always looked at, and I'm really bad at some of these things, like, I won't, but like with like those energy graph things.
Like this?
Yeah.
Okay.
Where you like have a reaction and it shows what the energy will be. And it's like, oh, energy is like,
Absorbed or something?
yeah, and like you like value it that way. I don't know if that's what
Okay.
it had, like.
Is this one for each thing?
I need to make a
Yes.
list.
Or like
I don't know.
the standard.
Oh,
I mean, like, I guess.
I don't.
Which energy?
Well, energy released during a nuclear process.
Versus energy released during a chemical process. So when I think about that, I'm just like, in are like, if you have sort of like a baseball size worth of uranium, there's like enough energy from fission from that uranium to be like this limits whole skyscraper full of gasoline. And like what is the reaction? So that's a good way. Another thing I think about is like actually calculate kilojoules per mole. How much is it for this reaction? How much is it for this reaction? Okay, so those are other ideas. So give her some feedback. Okay, what do you think it means about improvement? Okay, yeah, so like what? Like, I don't know, combustion reaction, like something. Okay. So like, maybe if they're given, a type of reaction, like combustion or sort of replacement, then they can predict what the react, or that products would be. And also, I'm not sure how they what's the same relationship? Uh-huh. Uh-huh. Okay. Yeah, so we've given some examples in the NGSS. It's limited to just read elements, which means like no transition elements. But you can do single replacement reactions, and you can do double replacement reactions, acid-base reactions. Okay. So maybe I think this one needs the specificity of the types of reactions, and I think we need to let it into that. Okay, so they learn. Don't you get it? Because like if they know that it's an acid-base reaction, then they should be able to predict, okay, we're gonna make water. And you said, yeah, going back to that, we played this one, right? The atoms, the predictable, yeah, the predictable way that they're doing it, yeah. Yeah, and then the other thing is like, so they're looking at atoms, or like atoms, so like a simple thing would just be like a synthesis reaction where if you have like sodium metal and chlorine gas, like you can make sodium chloride because like the chlorine wants the electrons. Do you guys that makes sense? Yeah, yeah. Thank you.
what if you can't really think too much feedback to give? Because like, they're all.
Do your best.
Okay.
Okay. Where are we on?
I'm on 3.3.
Okay, what's our standard? Design tools.
This is a chain of better way to communicate.
Yeah, so the,
Saying, just,
So one thing that I think is important about this is that they're designed chemicals, right? So that means like synthetic. Do you know what I'm saying? So when we wrote this standard, we were thinking about like DBT, like the
I was just
pesticide
like,
that killed the
said that's what I thought.
evils. Do you know what I'm saying? So we're thinking about like how you can design it for one purpose and like why you might design it that way. But then also then we're doing it to their consequences. Another example would be like designing a drug, like a pharmaceutical drug that would target a specific enzyme or something, but then also it would maybe have side effects or something. Yeah.
So I'm thinking, maybe get more specific with which particular situations.
Yeah.
And I think another standard area would be the students being able to, gather information on something. And
So
its
like-
impact on specific synthetic.
They might even have to like, for example, evaluate what resources, right, about these chemicals that they're looking into. Good? Okay. What are we working on?
Just identifying food stuff.
Okay.
Some schools got determined and we've got widespread findings, which I think will be a little clear.
Okay.
Whether it's actually conducting those reviews.
Uh-huh.
There's another one that's, there's data that was dropped on, so it's just prediction, but based on
Uh-huh.
data. So, and then compare and contrast and predict. So that you can cover.
Okay.
There could be more.
Well, those are like high-level learning objectives, but there might be basic things. So for example, they're saying they're comparing and contrasting elements based on size, electronegativity, or ionization, based on the periodic table before they can maybe compare and contrast them. They probably need to like be able to state the trends that exist and explain why those trends exist. Right? Do you know what I'm saying? So good. How are you doing here? I'm apparently walking unleashed.
I don't know,
Which ones are you looking at?
like which standard?
Which one are you looking at right now?
Sorry, no.
Okay, this is quite fun. So students will be able to fill in electrons according to Lewis dot structures for all atoms and ions.
So the only thing I can see is the all atoms and ions.
And so what would be better?
Probably on the last thing, like, evaluate the objectives to include performance targets, like, decide specific, molecules or atoms for them to focus on,
Like maybe even like monatomic, so atoms or monatomic ions,
Yeah.
right? Like, so very simple Lewis structures, but then they might also be able to, let's see. Yeah, I don't know whether there's another one here, but like if they're drawing Lewis dot structures for molecules, those are different than these.
yeah.
So is that something that they're gonna do or not do? What's the standard? 1.4? Yeah. Good, okay. So, yeah. It's a pretty vague standard, huh?
A little bit.
I think I wrote that one. Okay. So, so it doesn't specify here what the boundaries are.
Yeah, like where they're supposed to start and where they're supposed to end up.
Yeah, so like, I think it's fine to say atoms and ions, but probably we want to do something with molecules. So I would suggest adding in the like Lewis dot structures with molecules.
Okay.
So small molecules, I would say.
Organic chemistry.
We won't go into the organic chemistry definition of small molecules. We'll stick with, you could be more specific and say like molecules with one central atom or something like that. How are we doing?
I think we only have one per standard.
Yeah,
Okay.
So
that was my bad.
just make more. I think
Okay.
She tried to put it all in one. makes it difficult.
So you're giving her some feedback about what to do there? Other things she should write? Okay.
I'm sorry, I didn't do that mess to evaluation.
No, just
Okay. So which one are you looking at now? Yeah. Okay, I see. So what can she do to make this better? Like about what? Yeah, so being more specific about the types of processes. I mean, another thing would be to specify the types of changes in energy, such as like chemical to thermal, or, yeah. Yeah. What do we think here? Uh-huh. Maybe not like something that a student can do.
Right. Or just like, I mean, demonstrate might be good, but I think being more clear about, okay, how are you actually wanting them to demonstrate that? Like, what is the action they're gonna do to
Yeah.
demonstrate?
Okay, good. Also, different structural attributes of macromolecules.
Yeah.
Like what actually.
What actual?
So they might want to say, for example, for proteins, they might care about like primary and secondary and tertiary structure of proteins. You know what I'm
Right,
talking
yeah.
about? Yeah. So like that would be a thing that they might care about for that. Okay.
It's like clarity.
Yeah, the structure and the function relationship.
Right. So like here you talk about it needs to know actual structural attributes and which macromolecules are
Okay, I
and like identifying.
I don't know. It seems like it
Like here.
Yeah.
Exactly.
So I think that's what we're doing.
Demonstrate.
Yeah, so it might be, I mean, other things to talk about like relating structure and function. One thing might be to explain, for example, DNA, how the structure of the bases is related to the function of
I
DNA.
have to
That would probably match up.
include a table. of
And that it
so
needs to be that way
information
so that it can like be unzipped and zipped
that we
back up again
identified
and copies of it.
first.
Do you know what I mean? Like,
Yeah.
but there's functions that are related to that
Related to the structure.
Yeah, so maybe be more specific about a specific, an example of what that might be.
I feel like that's
Kind of blending with that then?
important.
Interesting, so like comparing different macromolecules and how they're structured, so like, that might be, it might be interesting, for example, for that one, I'm thinking, let's think about carbohydrates versus
Right.
fats, and like they're both energy storage molecules.
But like their structure makes it so that they're
And
different.
fats store more energy. Well, why do they store more energy? Well, it turns out they have like higher energy bonds, right? And than the sugars do. So, does that make sense?
Yeah, so that is, this is most of the ones I'm working on.
Anyway,
I'm
I
not
feel
quite
like,
sure
so
what-
I feel like we have ideas about how to specific examples, but.
I don't know how to write the learning update.
Yeah.
Yeah.
Just very.
Try, do your best about like maybe
Yeah.
giving an example of what
Okay.
you think this might look like. Or this is one way that you can be specific about it. And then they might want to be specific about something. You know what I
Different,
mean?
yeah.
Yeah. I think that seems fair. Okay. How are we doing here on are we getting close to being done going through the ones that we have? We need more time.
So do you want us to just do the first standard or do both?
I want you to do all of the objectives if you can, okay? And yes, you can have more time. We'll just take a break in like,
Just do like 2 more minutes.
yeah, let's do this. If you're done, you can start your break now. If you're not done, you can finish. And then we'll come back at like 1:10. Is that good? So if you need to take a break, you still have time.
like making these more specific, would that be like examples of like classroom instruction type things, like, so like if they had to like determine like electronegativity or something, or like recognize it like as like the electronegativity, the trends on the periodic table, like would that be, like would you put something in your learning objective if like students like would be given an atom and be able to identify like if it's like
Electronegative or not, or something?
yeah, or like compared to like
Yeah, so the learning objectives have to be connected to things that you can observe, so they're naturally tied to things that are like assessment type things. So for example, one thing you might ask students to do if you're talking about a trend in electronegativity is to just like describe the trend. Like the trend is that as you go up and to the right on the periodic table, atoms become more electronegative. Another thing you might ask them to do is explain why the trend exists. As they go from left to right on the periodic table, I'm increasing the number of protons in the nucleus. That increases the attraction that pulls on the electron, so it increases the electronegativity. Another thing we might ask them to do is, given two elements, compare their electronegativity or rank elements based on electronegativity, based on the trend. Do you know what I'm saying? So those are all things that could be specific learning objectives.
oh, so like
Everything I
students-
just said is a thing that could be a specific learning objective. Does that make sense?
yes, so it's like it's not necessarily like students will be able to like identify electronegativity on the periodic table. It's like that's more of like the standard like electronegativity, like they have to know that. But then like within that it's like they have to be able to do this. Like by the end of
Yeah, I think I see what you're saying, yeah. So like, we want our specific learning objectives. If students can do all of those indicators, all of those specific learning objectives, then they should be able to do the standard, which is whatever is stated.
which would be like several different concepts within. I don't know if what I'm saying is right or thinking my brain.
I think what you're thinking is right, yeah. Well, maybe take it until 1:15. Are you on a break? Are you done?
I really don't know anything very much, so.
Okay. Well, if you don't provide good feedback to your colleagues, it's like not gonna be helpful
I know.
for anyone, you know?
Well, the problem is, I don't know what I'm doing really well either. so When I made it yesterday, I was going over it, but I didn't know how specific to make it, how to word it, because
Yeah,
I get like we have to like, I also thought mine was pretty big standards,
uh-huh,
so I wasn't sure how in depth to go with macromolecules and all, because
yeah.
they give a few examples of proteins and lipids and stuff, but I don't know how to approach that standard,
Uh-huh.
so. I had a
So it
tough
was
time with
challenging.
it. Yeah,
Uh-huh.
as opposed to like the periodic table, there's like a million different things you can do with that.
Sure.
Macromolecules, I was thinking, yeah, they're useful, but on high school level, I'm not sure how depth or what to approach
Yeah,
that to.
okay.
So, had a tougher time with that.
Well, hopefully we'll get some good feedback.
Okay.
Can you like a review on this assignment?
Can you submit your
I don't
learning
know how
objectives?
good my feedback can be
Yeah.
for something. if I
Yes,
don't
you
know
will
what I'm
resubmit
doing,
that.
so-
Was this just like
In the
a
unit plan.
A for effort, like you wrote some things, or was this?
I'm gonna give you some feedback,
Not in high school.
and,
I think
you
we
will
talked
have a
about-
score.
Maybe the most we talked about was like.
And it
phosphorus
won't necessarily
by
be
layer,
like
how it's
representative
polar,
of
so
like, this
water
is the
doesn't
percentage
get
of standards
into
that
the
are
water.
good. But it's probably gonna be like, I see that
So I'm not
in none of your
sure
standards,
exactly
you included
how to-
behaviors of
Like I'm reading it.
So that's kind of big thing, because you're supposed to get that out of reading. Do you know what I'm saying? So like, that's
Yeah,
gonna
I'm
be,
trying to feel like
do you know what I'm
people
saying?
know about it, they need to do
I haven't,
something with it, and
looked at all of them
apply
yet.
it
We're gonna,
some
I think,
way,
look at
but
some,
that was-
I can put them up so they're not, oh, you know what? I need my, dongle. Who wants to go to my office and get a dongle? Anyone? Volunteers? Does anyone know where my office is?
No.
Oh, I do. You're next to Dr. Bronson.
That's right. Do you want to go to my office? It's just in the drawer that you pull out under the desk. It's the white thing that
Alright.
looks like a dongle.
Okay.
Okay. It's like the thing you plug into a computer.
you have to have like the special adapter thingy because you have the lightning or the USB-C ports?
Yes.
Did you find that
super
annoying?
annoying. Yeah, like today, I forgot my dongle. What am I gonna do with that?
Cry probably.
No, I sent Kevin to go get it.
I had to buy like this really expensive adapter thingy for mine,
Yep.
and none of them are cheap.
Mhm. Okay, I think before we go on, I'm gonna pull up someone's and we're gonna maybe go through a couple of them together and do this together. How do you feel about that?
You can do mine.
You're brave.
I will volunteer, you can do mine.
So I have it in a mode that just says student 1, student 2, student 3, doesn't
Oh.
say whose it is.
Okay.
Which standard
I
did
would
you
love
do?
to know. I did 4, 1 through 3. I think.
Question.
Yes.
So since I just like wrote it on paper because my laptop was having problems when I was gonna submit it.
Yeah.
When I do submit it, do you want me to just submit like what I have now, or do you want me to take like the feedback into account?
I would do a better job, yeah.
Okay.
Then I can give you better feedback, right?
Cool.
Okay. Student 1 has submitted no files.
That's probably me.
This is standard 2.1.
I think that was me, I just submitted it.
4.1 is the one that you did? No, I have it. If I said what standard it is, I have it.
Oh, I thought it said no files, I was thinking.
It just like, it labels people student 1, student 2, so that I don't know who they are. This is so that I can show you to you.
I was like, I submitted mine. How did it not work? Do we hand this back?
You're gonna give it back to the person. Uh-huh. Yeah, and then what should we do? Pass them one more along? Continue going the same direction, or pass 2 back the other direction?
Let's just go the same way.
Go the same way again?
Oh, somebody else, oh.
We're gonna do this one more time, but not quite yet. As soon as I have my dongle, I'm gonna,
I didn't really know what I was doing. And now I kind of understand. So, when you taught,
yes.
did you, like, give these to your students? Is that
Yeah.
like,
I put them on the board every day and I would talk about them, and sometimes if they had like a lab or something, then it would have a specific objective that was written on it. Like if they had a piece of paper, if I had a PowerPoint or something, then it would be in the slides, this is the learning objective for this PowerPoint, yeah. Being as transparent as possible makes it easier for them to learn things.
so you would literally be like, we're gonna go through this PowerPoint on
Thank you.
ask-based reactions.
Sorry, I didn't give you much to
And by
help
the end
with.
of it,
It's just like,
you
here's
would
Still
discuss
trying.
it.
Yeah.
It was good. And then like, if after that, if you had another activity to do during class, would you like have another learning objective for like each activity?
Maybe, but usually you have like sort of one,
Just like one thing that you work on that day?
yeah.
Okay.
I mean, 2 maybe. I want to get even bigger. Does it not allow me to zoom? Okay, there we go. Okay. So I think you guys mostly finished. Keep the papers for now that you've been working on, in case you want to change anything after we talk about the next couple. So this is somebody's that I pulled up randomly. I don't know which of you it is. Okay. We're going to look at the objectives for Standard 4.1. So Standard 4.1 says, construct an argument from evidence about whether a simple chemical reaction absorbs or releases energy, and relate the overall change in energy to the energy absorbed when bonds are broken and the energy released when bonds are formed. Emphasize conversion of energy from one form to another and conservation of total energy. Examples could include conversion of chemical potential energy to thermal energy in chemical or physical processes. Okay, so then we have these specific learning objectives. So, given different reactions, both pictorially with explanations and visually, students will be able to identify whether the reaction is endothermic or exothermic and list the evidence for each conclusion. What do you guys think about this?
I don't quite get the difference between pictorially and visually.
I agree. I don't really know what the difference is between pictorially and visually. Yeah?
I forgot what I was gonna say, never mind.
But it looks like, so the standard is whatever it said, and then, so this is one part of it, endothermic and exothermic. So you want to be able the students to distinguish between those two.
Okay.
When they can do that, then they can move on to like another learning objective.
Okay.
Is that kind of like what we're looking here?
Sure. So like I think what I hear you saying is there may need to be a learning objective that comes before this one. Like before they can look at diagrams of some kind and decide if it's endothermic and exothermic, they probably need to know what endothermic and exothermic are. Right? So like maybe we would say something like define the terms endothermic and exothermic for chemical or physical processes. We might want to talk about system and surroundings as like a thing that's important for them to understand before they can define endothermic and exothermic. Are you with me here? So there's some like, there's probably some preliminary things that need to go into it. I think the purpose of what's written here is because they're trying to say, okay, if we had a reaction where, for example, we were breaking 5 bonds but forming 10 bonds, then we might think that that reaction was exothermic. Is that sort of the goal of what this?
Sorry, I'll just say it's me. Where I was going is like if we showed them like pictures of like a reaction taking place and like gas coming off and like had an explanation, but it got hot. Or like the visually, I couldn't think of a word for, I guess a good word is like experiments, through experimentation.
A demonstration.
Like where they can actually like feel that it's hot. Like can they be able to identify and put in their mind, okay, this is exothermic, endothermic.
Okay, so maybe what you're saying is, maybe there's a standard that's like define what the terms endothermic and exothermic mean in terms of system and surroundings in a chemical reaction. That might be one. And then there might be another one, which would be like, based on changes in temperature, identify whether a reaction is endothermic or exothermic. Or classify reactions as endothermic or exothermic based on changes in temperature. Right? Is that kind of what you're thinking? Like they could sort of feel it and they'd be like, oh, this one's hot, that means it's exothermic. Yeah. Okay, good. So I think that we would modify those things accordingly. I like that this one has this idea that students are making a claim about whether something is endothermic or exothermic and supporting it with evidence. So I think that's something that we would want to maintain, even if we modified it to say that it's based on, temperature changes or something like that. Okay, and then I think, okay, so the next one says students will be able to use the change in enthalpy equation and the values for different bond energies to prove mathematically, I think that should be mathematically, whether a reaction is endothermic or exothermic. I think this one is like pretty specific. I might phrase it differently. I don't think I would say that we would prove it mathematically, but we might say that they can calculate it, or the catchphrase with science and engineering practices is like use mathematical reasoning, which means like calculate things. Among other things, right? Like comparing numbers and stuff like that, but use mathematical representations for bond energy to decide if a reaction is endothermic or exothermic. Yeah.
So, like before in the previous learning objective, you talked about how you would probably want to break it up and say like if a reaction is endothermic, like what is endothermic, what is exothermic.
Would you also include like what is enthalpy in that situation?
Oh, yeah.
Like,
That's a
I
great
don't really
question.
know
Yeah.
how to like group things together,
Yeah.
particularly with like teaching them, but I don't know where that would fit.
Yeah.
Is that where it would fit? Like,
Maybe, it depends what you want to do. So like, enthalpy is a very difficult thing to teach. I'll tell you that now. Even here, it's like really hard because it's like, you know, the change in free energy minus the change in whatever, I don't even know, without minus the PV word or something. Like there's a weird equation for it. And it doesn't really like make sense. So when I think about enthalpy, I think about enthalpy as essentially potential energy associated with chemical bonds and intermolecular forces. So it's a type of potential energy that's based on the attraction between opposite charges, you know, fundamentally. And anyway, teaching that to kids is hard. I think it might be easier to teach to kids the phrase bond enthalpy, like to use the word bond enthalpy as opposed to bond energy, even though they're like the same. Do you know what I'm saying? You see them in tables written both ways. But use the word bond enthalpy and then teach them that enthalpy is like associated with that chemical bond. And you have to add enthalpy in. Enthalpy is a type of energy. I don't know. My point is you can decide, or you can decide where it wants to go, but you have a great point that enthalpy is a term that we probably have to talk about. In high school, I don't think students are going to understand. Who here feels like they understand enthalpy? I don't.
can you spell enthalpy?
I can spell enthalpy, yeah. I mean, and I feel like I have a general sense of like, you know, the chemical potential energy. That's how I sort of refer to it, because that's basically what it is, but like precisely mathematically it has like a sort of different definition. And so the degree that you're going to get into that with high school students is like probably not that much. But they need to know what it is a little bit so that they can do these things. Okay. Let's look at the third one. Given different scenarios, students will be able to identify where energy comes from and what it is being converted to. Okay.
But you want to talk about different kinds of energy? I mean, I know that the standard doesn't specifically talk
Yeah.
about that, but like, maybe, this is something that we were like kind of talking about, was that with these standards, like since we're just doing our few, we're not doing like all of them, that it's kind of hard because it's like, maybe you'll have something like energy where previously it was talked about, like you did talk about different kinds of energies according to all list of standards, but like in your specific three, it's like assuming that the student already knows and has
Right.
had a lesson on different kinds of energy.
I think it's okay to say that in your lesson plan, like I'm assuming this prior knowledge. I think it's useful for you to, as you're doing things and you think, gosh, will they have learned about this somewhere else, to look at the other standards and have a sense of like, would they have or would they might maybe not have. And then that gives you some guidance about whether you include that. Okay, there's this last one here. I'm not sure what it means in terms of energy coming from and what it's being converted to, unless it's saying like that energy, maybe like chemical potential energy, might turn into thermal energy. Is that the idea?
Yeah, it talked about the,
It's very much.
The conservation.
Conservation,
chemical
it can be
potential to
converted from
thermal
one form
energy.
to another. Okay. Yeah, so I think you probably want to be more specific, because like where does energy come from? I don't know what that means.
Okay.
But like maybe you might want to say like classifying the types of energy, or given some chemical system or chemical process, describing the forms of energy that are converted or something like that. I don't know. Okay. You can probably tell, because this is not like a science, making the learning objectives. A lot is going to depend on the context, right? Things that you're going to know that they know because they took physics last year. Or other things you will have talked about earlier in the year, or that you know something else is coming up later in the semester and you want to kind of like preview that idea. now. And a lot of it will depend on whether you're teaching like in a really good school or in a not so good school where like students maybe don't have the same preparation that they would in a different school. And so you're maybe not going to get as deep with those students as you would in a school where they have like really great science classes like their whole life, you know? And so there's a lot of context that goes into this. So it's not like there's one right answer to what the specific learning objectives should be. So you have to use your judgment about that. Does this, like what we just talked about, does that kind of help you a little bit with your evaluation task? Like looking at the other people's? Yeah? Okay. Do you have a thought, Kevin?
I'm just looking at this and I don't know. I think I would like to do this again after, you know, people have had time to put into practice what we've been talking about.
You want to do what again?
Well, I just feel like these this criteria would be more what is the word? Relevant. That's the word. Yeah, more relevant to the assignment after we've done it, after talking about how to do this. I feel like there were a lot of us who didn't quite understand that we needed a many and more specific and more detailed.
So the thing that you would like to repeat is the process of evaluating other people's?
Yeah, after they've had the chance to rewrite their things.
So
Okay.
instead of doing a second evaluation right now, rewrite and do the second evaluation later.
Yeah, that's
Do
what
you
I'm
want to
saying.
do that right now? Do you guys want a chance to rewrite what you had based on the feedback, and then we'll do a second evaluation from a different person?
Yeah.
Okay,
We don't
well,
have to do.
No, you don't have to do
Like
this today.
We can,
But
next week.
I was just saying that like, from this criteria isn't super relevant for where we were at in learning how to write learning objectives.
I
it was
think
helpful.
what I'm saying is I believed that you were capable of doing this based on understanding and thinking about that reading,
Mhm.
which is why I gave you this task.
Okay.
But I understand what you're saying, that it might be helpful to do it again. You're thinking in particular that you would like feedback on your learning objectives that you wrote.
Oh, no, I'm confident that you gave me good feedback.
Yeah, I'm saying you want to try rewriting them and then you want more feedback.
Yeah, I guess that's true too.
Okay.
I was just, I don't know, I feel like many of us had maybe one or two learning objectives for each standard.
Okay.
That's what I'm saying, I guess.
Like, I didn't realize I was supposed to have so many. Like,
Yeah.
I wrote like 3
Well,
or
we-
4 per.
Talked last week about how you might spend several days about
Yeah.
things.
Yeah.
So I thought it was clear, but it was not clear.
I think my idea was generally like, the learning objective was kind of like an all-encompassing, by the end of the unit, this is something they should be doing, instead of like, this day, we're gonna teach about this small
Yeah.
portion.
Okay.
Like, these are kind of like, I'm thinking of,
The reason that
Yeah.
we have these things
Yeah.
is because the standards are not written in a way that is conducive to thinking about
each day.
teaching.
Specific,
Do you know what I'm saying?
Yeah.
Which is like, so you have
Yeah.
to translate them into learning objectives. That's the idea.
Yeah, I agree with
Okay.
that. I just didn't realize like.
Nobody understood what you were supposed to do
Yeah.
in this assignment. Okay.
Cause I think we were all thinking of them more as like an end goal, like on
Okay,
the
Like
test,
something
they'll be
you'd
able to
see on, like,
synthesize
the
all this
syllabus, like,
information.
by the end of this class, students should.
In the
Okay.
reading, it was talking about how the standard is so closely related to the learning objective. And then it mentioned some things about, you know, sub-objectives at one point in the reading.
Yeah.
Make different like goals and sub-goals, and it's like, you can't reach your sub-goals, then you
Yeah,
have to
that's
throw
right.
some out, and it's like,
So in my mind, like
Oh,
these kind
like,
of
I
things
don't
were
know.
sub-goals.
Uh-huh.
So I understand it better now.
Okay. Good. Okay. I need a second to think. I feel a little bit stressed about like, I'll think out loud. Fair?
Yeah.
I feel a little bit stressed about like saying taking another week on like translating into learning objectives, even though it's like really important, because we have to talk about assessments and we have to talk about like activities that you do in class, and that's like a lot of stuff to talk about. And so I don't like the idea of like necessarily like having another week that we do it. On the other hand, I see from all of the submissions that like there's a lot of problems with what was submitted that's like not gonna be good. So you probably need to redo them. And it might be helpful if you had one more iteration of feedback before you have to turn them in, like for your unit plan at the end of the semester. But basically what we're doing is like, we're writing the learning objectives now, you get feedback, you fix them, and now you're gonna use them as you're planning your unit plan. Did everyone understand that part?
Yeah.
Okay, good. Good. Thought?
What if a compromise is we write them and then turn them in like midweek and then do evaluation as like a homework assignment before next week? So we come with them
Okay.
done, and, I mean,
Like
let's work
evaluating
outside of
somebody
class.
else's or something?
But yeah, like if we turn them in like
Yeah.
Monday or Tuesday online, and then people
And
could,
maybe you have to like email them to a partner or something.
yeah.
Or if it's like quicker, if we just submit it, like, I don't know how long it takes you to get feedback on them.
It'll take me a really long time.
Yeah.
Okay.
Cause that would,
But
like,
I would rather give you feedback on a new version than the version that I have seen already.
yeah.
So what if we do this? Okay. What if, okay, Okay, what if we just change the due date from the formative assessment thing, or sorry, not formative assessment, it's the next thing. We change the due date from learning objectives, and we make the same assignment due again next week. And so between now and next week, you guys have to redo your learning objectives and make them better, and then I'll give you feedback on them. Yes? Does that satisfy your needs?
Yeah.
Okay.
Could we still keep work, like, do stuff on formative assessment as
Yeah.
well?
Yeah.
Maybe we can-
So
Well, do you like a
Understandable.
reading on formative assessment? I think we can, so is it okay to do that then, that you would have 2 assignments that are due next week?
Yeah, that's fine.
Yeah.
We're just
Okay.
gonna make ours better. I
You just
think.
need to do it again.
And then we can get feedback and
Yeah.
then still move on to the formative.
Because I don't really
Okay.
think it's gonna take anybody like that long to fix their work. 'Cause
Okay.
I think we all had like a pretty, like,
Now you feel more confident in your ability to do it.
yeah.
But I think we
Yeah, so
understand
go off of 2.
formative assessments enough that we could do that
Maybe.
while we're doing it.
Okay, let's see,
Hopefully.
okay, we're gonna talk now. Okay, so now give your feedback forms then to the other people. And the other ones that you didn't use, we'll just like recycle, I guess. Or if you wanna keep it, you can use it to evaluate yourself. Yes. Okay. Okay, now, we're a little bit behind even today for what I wanted to be doing, but we're talking about assessment. Now, who here has any ideas about assessment that you know about? Ready, go.
A worksheet.
Okay,
Or like.
what I mean is like types of assessment. So I guess what you're saying, yeah,
Like tests, quizzes.
so tests,
Worksheets, quizzes.
worksheets, quizzes, huh?
Reports.
Reports or labs, yeah? What else?
Video project.
Video projects, what else? What other kinds of
Essays.
assessment might you do? What about something that's not written?
Yeah.
Listening on conversations.
Listening on conversations. What about having a class conversation and using that as an assessment of understanding, right? Having polls, putting people's heads down and like raising their hands for like what they think is the right answer or something, you know, like, okay? So there's a variety of different things. There's basically 2 dimensions that we're gonna think about assessments on. So one of them is formal versus informal. And the other is formative versus summative. So some of you guys said you had a sense of what formative assessment is. So who wants to tell us about that? Kevin?
A formative assessment is, it's an assessment that gives you an idea of where people stand as far as understanding what you've been teaching. It's more of like you're testing where they are, how much they understand, how many of them understand how much.
Uh-huh. And why would you do that?
So you can change, change what you just taught them for the next class and also to
adjust instruction, what else? It also gives the students feedback. Huh?
It's like a checkpoint.
Uh-huh.
This is what you're supposed to know by the end, and here's what you're doing right now.
And it gives the students feedback, right?
Yeah.
So not only is it information for you, it's information for the student about how they're doing. Okay? A formative assessment could be something like a quiz that's written, and it could be a conversation, a class conversation, it could be a poll, it could be a ticket to leave. There's a variety. We have a worksheet that we're going to look at in a minute that's going to tell us about 50 different kinds. It might be 25, but it's like a lot. We're going to look at that in a minute. Okay, what about summative? Yes.
Summative is more like a final assessment to like assess their performance.
Okay, so it's an assessment or an evaluation of performance, right? So what's an example of a summative assessment? Generally.
End of unit tests.
Yeah, so like an exam, it could be a unit exam, or it could be like a state test at the end of the year or something like that. The purpose is to evaluate performance. So you're going to assign grades. Generally, formative assessments are more like you get credit for doing this, but we're not going to judge you right now based on how well you're doing. And summative assessments are like, now we're judging you based on how much you've learned. Yes, this could also be like a lab report or a presentation or something like that.
Could homework be considered a formative assessment?
Absolutely. Sure, yeah.
But could it also be
Depends, I think homework would never be summative. It would be weird that you would have a homework assignment that was summative. It would mean it was like the last one at the end of the unit that tested everything. It'd be like a take-home test. That could be a summative assessment, you know, but.
or like if you gave homework on like the chapter review problems or like.
It's
or
still,
not even
because
that,
it's
no?
homework, it's like a formative assessment.
Okay.
Yeah. Do you agree with me? I can't like imagine a world right now where homework is a summative assessment.
Because even if you do like review problems, you're generally doing them to prepare for like a test?
To prepare for the
Okay.
test or something. Because there's, the summative assessment is like the final end of the unit like thing. Okay,
I think
good.
that ties to being more formal rather than informal for the homework.
Okay.
Yeah, so for example, you basically will never have an informal summative assessment. That would suck. That would be like, at the end of the year, the teacher is like, you get an A. Do you know what I mean? Like, I'm not gonna tell you how I did.
Oral
Yes,
conversation.
Yeah, we have the conversation at the end. Do you know what I mean? It's just like sort of weird. Really? And you didn't like it, did you?
I mean, I did.
You were
because
like, I got an A. But if you didn't get an A, then you might be upset about it. And even if you got an A, like I always want the feedback, you know? So anyway, so formal versus informal. Technically, the definition of formal is that it's like standardized. So things like the end of year test, like the SAGE tests, are you with me here? Those are like the formal assessments. So these are supposed to be like written, generally they would be written, standardized, and sometimes also normed, meaning that there's like a sample and they can tell you what percentile you are in the population or whatever, right? I tend to think of formal assessments like if I give a unit test, I think of that as sort of a formal assessment. And technically, most teachers don't have like a bunch of data to say like how students should perform on these items, but like you might. So we'll use this word loosely. Technically, it has a more stringent definition than the one that we'll use, which is sort of like a written exam. Informal, or a written assignment of some sort. It could be not written if it were, for example, a presentation and you had a rubric that you were using that was precise and you were grading your presentation that way, then that could be formal also. Okay, informal, these are things that happen spontaneously. I mean, they could happen spontaneously. You will plan them judiciously in this class. But you will hopefully develop facility over time to be able to say, I want to check in and see how students are doing. So hence, informal is often related to formative, right? And formal is often related to summative, but it's not necessary that it be that way. Informal, they might be just oral or spoken or an observation. I think of them also as like, there's no written record. It might also be something that like, you're just gonna glance at, like a ticket to leave, I think of that as informal, right? Does that make sense? Okay. So let's say like no written record, those are approximate definitions for us to work with.
Sorry,
Okay.
this is a dumb question, but what's a ticket to leave again?
A ticket to leave, we're gonna learn about with this paper that I'm about to give you. A ticket to leave is like at the end of class, say for example, you learned about gas laws today. You wanna know, can people solve a problem with PV equals nRT? So you give them a half sheet of paper and it has a problem on it. And if they wanna leave class, they have to turn it in. It's a ticket to leave. So the last 5 minutes of class, they'll have to spend on that. And then as soon as class is over, it should be pretty easy for you to like sort them into like different piles. These people get it, these people don't get it. Okay, let's pass this. Okay. That was super boring. I try to not talk as much as possible, you guys. Now, this is a collection of a whole bunch of different formative assessment strategies. This is what we're gonna do. Each one of you is going to choose, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, there's a lot. So we'll divide roughly by pages. There's one page that has like a big one, so then I'll make that maybe 1. So like, hold on. Okay. 1, 2, 3, 4, 5. There's basically 5 pages, and this last one. Counting is like not my strength in the afternoon. Do you guys ever feel that way? Okay, this is what we need to do, you guys. Let me explain what's gonna happen, and then you're gonna tell me how to do it, because I can't figure it out right now. Are you with me? Okay. I know that I thought about it before, but I don't remember what I thought. Okay, this is what we're gonna do eventually, is each one of you is gonna choose one strategy. The thing is, I don't want you to choose the same strategy. That's why I'm struggling here a little bit. Okay, each one of you is gonna choose one strategy, and we're gonna make 2 circles. We'll have an inside circle and an outside circle. And we're gonna face each other. And then I'm gonna explain to you my strategy, and you're gonna explain to me your strategy. And then the outside circle is gonna rotate. So now like this person will explain their strategy, and that person explains that strategy. Are you with me here? Okay, how do you want to divide them up? That's the question. How do we decide who gets to do which strategy? Because you shouldn't choose the same one. Try to choose one you haven't heard of before.
I'll move my letter. Thank you.
Easier for you then, Erica. Other people might have heard of them before. So how about you guys choose ones from the first page? This is what we'll do. Choose ones from the first page and check with each other it's not the same. Choose ones from the second page. Check with each other it's not the same. Choose one from the third page. Check with each other it's not the same. Choose one from the fourth page. Check with each other it's not the same. Choose one from the fifth page. I'll choose one from the fifth page too.
I was just kidding, I've heard peers, I'm familiar with homework quizzes and tests. My bad.
Yeah.
Oh.
I like the case one.
All right.
I like the cures. Yeah.
What are you thinking? Smart cards? Okay. Choose good one. Okay, I'm gonna give you 2 more minutes. You should be able to explain your strategy without like straight up reading about it. So like, use your own words.
Wait, sorry, what was that?
You have 2 minutes to prepare yourself. You need to learn your thing well enough that you can talk about it without looking.
Oh.
I'll let you look.
I'm doing that. Oh, it's fine. You're right there.
Are we practicing with our?
Okay, let's stand up, you guys. 1, 2, 3, 4, 5. You're on the inside circle. You're gonna be very close together. And then the rest of us are on the outside circle. You can bring your paper with if you want, and you can also bring a pen if you want to like star the ones that the other people are doing, for example. Okay, inside circle, it needs to be a circle. So like, do you understand? Yeah, good, good. Good, and now I'm lined up here. Good, good. Okay, inside person goes first. On your mark, get set, go.
The teacher is just going to summarize it.
Minus one, S, O, S, the first one is
But this is
and
what
then
it
S is report. So they have to have evidence to say why they. Okay.
Mine was.
You done? Outside person? Did the outside person go? Oh, outside person go.
Okay.
This is what we're doing right now.
So yeah, like, they have tasks, so like if you ask them a question that I haven't really answered, they can ask her, and you like, how many times have you used it a day, or like, exactly, like, use it for,
Definitely harder. Yeah. I like the SOS because there's lots of.
You can give to like alphabet states and like shoot out like little things.
Okay, stop. Outside people, move to your right. Okay. Outside people go first this time. I'm ready to go.
Okay. But they can't do it without giving you.
They have to provide
No, just their.
I like this strategy because you can try instructions, like you can all molecules are made from at least and then okay, switch.
One question based on summarize.
So they'll like fake it and be like, I had or they usually like one day like a row and then like the column says like one and then what all one. This time it's just forcing you to stay down. So I feel like teenagers are smart enough to think that
Yeah. Same thing that we're doing now. I'm like, I'm so clever, I was like, I still actually make it go help me.
Yeah, sure.
Cards generating. Okay, switch. People on the outside, go to the right again. Inside people first.
Summarize, explain, or value, or every time the teacher's asking a question to the student,
Unless you want to, that just they might be right, not just.
Switch.
Yeah.
Okay, common for
So, you give them a So you like ask me questions like first, right, and then like, okay, you answer this question and they feel like they don't have the answer or whatever, and they can hold up their hand. Or like, you as a teacher can like set, yeah, and they just decide for it. So like, that helps, like, you have to, I don't know, you have to like really think about, okay, like, you only use it twice a day. Or like, you can only use it for like, certain types of questions. Yeah, so it's good to like, it helps them feel like a little bit.
So
you think which kind of class?
So that's.
Yeah.
So it wasn't just give us something else, right?
No, it's just pass, so that you don't answer it. And then it like makes it so you can more easily say, okay, I can call randomly because you have a snapshot.
Yeah. And I have people, if I were doing it,
I'm sorry, I just.
Call you randomly because I
Okay, switch.
I don't know what I'm saying, whatever.
Alexander person goes first. And
Mine is
So-
on
Okay, so
is.
extracurricular-
Actually, that I also.
So like, anytime there's a day that you're out, so also
Like, right,
they don't have as this person, so like, you have to limit on like, okay, you can either like.
I like this
go
one.
or like, other understanding that I
Also
also
time
and whether or not they like really grasp something.
Then you can ask them more right,
which is like not as your same one,
but they also.
Let's see where they're at that way.
You know, what
But
is
they
it
want
that
to
you
drop
feel like
something.
you remember
Yeah,
from
so then you can
the?
like, have to do that and then like have a few like,
I mean, I took it as just kind of like writing a question.
Yeah. So like, I don't know, it's not like they're just a diary or something, it's like a specific, like, this is like chemistry.
Yeah.
I know.
Switch.
You
So you can actually go
I mean, I'm sure I read it.
What like changed
but I like it.
want to?
I didn't remember it.
Yeah. But like, okay, we're gonna do that tomorrow.
Okay. Awesome.
Inside person goes first.
I have.
Teacher creates a.
So I just want to.
I thought it was really
The question teacher was gonna just say something.
Summarize, they'll ask the question, summarize it.
Because it does a lot.
Yeah, that's but like,
Well, it also helps with like, that's like, okay, like, I experienced that, so that's what that relates to, okay, now I like understand.
Okay, so I'm not just like regurgitating things, I'm pretty sure what my teacher wants me to know, like, okay.
when you're in and you can then maybe like.
And so like, as you ask them questions randomly throughout the day, they'll understand, if they decide like, they don't want to answer a question, really don't know the answer, they just want to answer. So it's kind of a nice way, like, okay, we're gonna ask random questions, but it also like, gives them a little bit more understanding.
It's like, what was the best?
So, it doesn't like, it's not that up to you to decide like, okay, you get your pass once a day.
Yeah.
Like, you can only pass on like, maybe math questions, but you have to answer all of the summer questions. So like, it depends up to you on what you see it, how many questions are asked today.
Or yeah, like one.
Right, so you definitely have to like.
Okay, last person, switch. Right? One more time?
we're done.
One more time. Okay, we're done. That was fun, you guys. Did you have fun? Somebody tell me about one that you learned about that was not yours, that you didn't realize you were going to know about, or like, but you liked it. Are you with me? Yes.
I liked Ammon's The Spinner,
Yeah.
where you like have the different categories and then you spin it and like. Then I was thinking after I heard his, you can combine it with Scott's with popsicle sticks. Because then you like spin it and it's like totally random. It's like
Yeah.
so-and-so's gonna answer whatever.
It's going to be a
So that'd
summary.
be really fun.
So-and-so's going to answer as an evaluate.
Yeah,
You just have to be prepared before the class with like, what's the evaluate question?
yeah.
And what's the summarize question? Because otherwise you might be sad. You'd be like,
I always
Yeah.
actually think of it as a way to help me think of a question, that it's just not,
Yeah.
what random question can I ask about
Yeah.
this topic? It's like, oh, I need to ask a summarized question on this topic. So it would help me, I think. But-
On the spot, if you were coming up with questions on the spot. But I think if I were using it, I wouldn't take that approach because it would stress me out. Because you saw I couldn't even count like on the fly. I struggle. So I would probably prepare the questions in advance.
So you can even have more than one of each question. So like if it
Yep,
lands on
sure.
summarized twice, like the next student isn't like, what he
Yeah.
said, you know, then they have a different question that they can
Yeah.
answer.
Yeah, good. Okay, one more someone else shared something with you that you thought was cool. Yeah.
Probably Kevin's exit cards, where you get a card and as they're leaving, maybe they write something that they learned, something that they didn't understand, so you can get a feel for like where they were at that day. Or-
Good.
Yeah.
Like a ticket to leave or something.
Mhm.
But then you can combine it. Sometimes there's a 3-2-1. Did you guys see that also? 3 things you learned, 2 things you have questions about, or you didn't understand, or like 1 thing you didn't understand, 2 things you have questions about. Do you know what I'm saying?
Yeah. That would be-
So that's a nice way for you to know at the end of the day like what's going on.
So I feel like towards the end of classes, at least when I was in high school, the last 5 to 10 minutes, lots of times there was and then you're just sitting there till the bell rings. So that would be an easy thing to like.
I think
do.
it's super, super important. Thank you for telling me that. I think it's super important. You should know that your students, the thing that students remember the most about is what happens in the last 5 minutes of class. So if you're not using that time productively, you're not helping them remember. And so summarizing at the end of class of some type is really important. Like at the end of class, you should always summarize what did we learn today. In some way. Maybe it's by doing a problem, maybe it's by listing out what I learned and what I don't understand. Any of these strategies, right, could be used for that. Finally, there was one more thing that's really important. You should always have your goal, and this is with regard to formative assessment. In your unit plans and your lesson plans, you must always, this is a requirement for them, have a formative assessment associated with each lesson. Because you should never finish the lesson not knowing whether your students understand. Remember, you're not here to tell them stuff, you're here to help them learn. If you don't know at the end of the day whether they learned something, you don't know whether you've done your job, right? So you always want to have a formative assessment. Good. Okay. Good. We're on schedule again. This is so good. Should we do this? I think we should. Okay. How do you feel about formative assessment strategies? There's a whole list of them. Guess what you get to do for next time?
Prepare?
Yes, you get to prepare 5 formative assessment strategies. In the end, you're going to need more than that, right? Because you might have like 7 to 10 days of instruction, something like that. So you need at least 1 for each day. But 5 is a good solid start. So you're going to prepare 5 formative assessments. At least one of them has to be formal, like written like a quiz or something.
For our
Learning objectives. For the standards that we.
You're doing this for your unit plan. Everything that you do is for your unit plan.
So we're not bringing 5 to class to like present, we're bringing 4 at UConn.
Yeah, you're bringing them for your unit plan. But I've given you an example on Learning Suite. Let me see where it is. Do you guys have Learning Suite? feel like it's under week 3, maybe. Where did I put it? Sample. Oh, it's in the description. It's in the, if you look at the assignments. Are you guys here with me?
Home for Wednesday.
The assignment that's called formative assessments, that's due 1/31. If you look at that, in the description, there is a document you can download. Do you guys see that? Okay. So I'll download it here and then we can look at it. Okay. I think that it's a common occurrence for me to give people assignments that they don't fully understand. I would like to make it the practice that before we leave, you ask me all the questions that you can imagine having, so that we don't end up with another situation like today. Do you know what I'm saying?
Yeah.
Will you promise to hold me accountable to that? Because I feel like I explain things, or like you understand things, and then you're like, we don't understand. Do you know what I
We
mean?
thought we did.
Yes.
I mean,
You thought we did,
We
yeah.
thought we did.
I don't know if we would.
I thought you did too.
We all probably run.
Okay, so this will hopefully help this week. This is an example. So we have, this is a quiz on atomic structure. This was written with old Utah objectives, but it would be like at the end of a lesson about the history of the atom. And then I want you to notice some things here. So number 1, I've stated what objectives it's targeting, this formative assessment. Yours should do that too. Number 2, I'm providing some description here that's like teacher instructions, like this is where it's going to happen in the curriculum. They can trade papers and grade the quiz, and so they'll get immediate feedback. Do you know what I'm saying? So I've kept in here instruction that makes it enough instruction that somebody else could pick up this document and be like, perfect, I'm on my way, ready to go. Okay? And then I've included here, because this one is written, I've included the quiz that we have, and there's a couple of different types of questions and stuff, right? And I've included an answer key because it's a quiz. Yes? Okay. My second one, this one is called paired verbal fluency. We actually did this in here, I think. It's like person A and person B. I'll tell you that. And so this gives, again, it tells me what objective it is. It gives the teacher instructions about like, this is what you're going to do. And it gives the specific prompt. So like, which type of radiation has the least energy, which has the most energy. So it gives all of these things, I guess, are part of this prompt. And then it has more instructions for the teacher. So the nice thing about this is a teacher could come, just pick this up and do it, and it doesn't take any additional preparation. I point that out because that's like the level at which your lesson plans and unit plan and assessments, everything that you turn in at the end should be written that way, because we're going to remember we're going to be sharing them, right? And so you want it to be like production level quality for your colleagues, right? Okay, I think these are 2 formative assessments. So these are 2 examples of like what that might look like. Yes? Yes? Okay, so one of them has to be formal. If it weren't a quiz, is there something else that could be a formal formative assessment? Thoughts?
Could make like a worksheet that the students turn in at the end of the day.
So some kind of written assignment. I think that's sort of the difference between a formal and informal. I think that this one would always be scored. I didn't write that before. Okay, so we would have an answer key of some kind. I think it should be written somehow. Maybe it's a worksheet or a quiz, something like that. The informal formative assessments can be any of the strategies that we talked about today, any that are here Those are all acceptable. The important thing is you're going to be doing it so that it's like applied to this situation. So like, let's think of one that people talked about today. We talked about an application card. Did you talk about that?
Yes.
The application card. So like if you're doing an application card and it says, write down one real world application that applies to this topic. Well, if you're doing that for your formative assessment, then you're gonna be specific about which lesson this is happening in, what would you have talked about in class, when this is gonna happen in class, what's the prompt that you're gonna give them, what topics would you give them, to talk about. So like, what topic would they write about for this? Does that make sense? Yes.
Okay, so if we do this is like one day, one learning objective on, like, does that make sense? Kind of like one learning objective, these are the formative assessments for this day, and then another day we would do this learning objective.
Yeah, so ultimately, at the end of the semester, when you have your unit plan, you will have a formative assessment that's associated with each day of instruction. So you're going to start thinking now a little bit about like how you might break up the ideas that you have, maybe into different days, right? Yes?
So for this particular assignment, do you want us to have like formal and informal? Can it be
The
either or?
requirements are that you should have at least one formal and at least one informal.
Okay.
You can combine them in whatever ratio you want as long as you have at least one of each. And you should turn in 5 for next week, okay? Those, you can change them obviously afterwards if you want to change them before you have your unit plan. And they won't be all of the ones that you'll need for the end of the semester. So if you're on a roll and you want to just be like, I'm going to do 10, then like go for it, Okay,
We
Ashley.
do, like, could we repeat some, like 2 quizzes or like, I don't know, 2 of the same one?
Good question. I don't want you to. Is that fair?
No.
Okay, yes.
So for the ones that are like the 3-2-1 summarizer,
Yeah.
there's not like a ton of work to like set that up, because that's kind of like based on them. So you just say like, this is the lesson I would use it with.
Mhm. These are the objectives that I'm hoping that students would learn. So you have to assign it, it should have like the objective and then like the context. And then 3-2-1 doesn't need anything.
Right, because you wouldn't write a question, but you could maybe say like, I'm looking for them to understand this. Here's
Yeah,
where they
you
might
might-
have questions.
Yeah, you might anticipate, I think that these are some things that people might understand or something like that. Yeah, that would be good. Yes.
If we submit more than 5, will you give us feedback on all, like, or not necessarily?
Probably. I mean, maybe. I'm not sure. It's going to be to depend like what everyone turns in. If people turn in like Mondo crazy stuff, if you turn in 10 each, I might die. Because it takes like a long time because I have to think about so many things. Do you know what I'm saying? Like you have to think about so many things when you're writing them. Okay. Now, other questions about the formative assessment stuff for next week for this assignment? Do you guys feel like you understand? Okay, yes.
Does this go on our unit plan template?
Yes, it does. It goes in the assessment plan part of your unit plan template. All of this is described on Learning Suite. I can't show you that page right now because it has like your grades, I think. Oh, no, it's assigned, it's here. Can you guys, no. Can you see this? So select 5 formative assessment strategies from among those we discussed in class to use in your unit plan. You must include at least one formal and one informal assessment type. Each formative assessment should be at least 2-dimensional, preferably 3-dimensional. That complicates things, you guys. That's going to limit the specific types of strategies that you're able to use. Like you might not be able to use 3-2-1. Are you with me here?
Yeah.
Or you'd have to give it some more specific structure to make
What
it
are 3 core concepts that you like to?
disciplinary core ideas. And what are 2 science and engineering practices you learned you used today? No, I think that you'll be creative about it. Okay, and then your final unit plan will have to have a formative assessment associated with each day of instruction, which means you'll ultimately need 8 to 10 formative assessments. And then prepare an assessment plan, this is where it goes in your unit plan, that lists each activity, the Utah standard it's addressing. And I think, so this one says the Utah standard, I think it would be helpful if you gave this specific learning objective as well. And then describes how each assessment will be implemented in class, like that context. And then if there's like a handout or an answer key or something like that, it should include that as well. So it should have enough detail that another teacher could carry it up. You're gonna add this on to your unit plan template. You know what, maybe this is what we'll do. Maybe instead of moving the formative assessment ones, since you're gonna submit your unit plan template next week with the assessments added in, maybe just fix your learning objectives on there as well.
So don't submit twice, submit once.
Yeah, just
But
submit it here and I'll look at both of them. Yeah? Or do we want to submit it twice? It might be easier for me to grade it if you submit it twice. I'm going to come back to that. Okay. Good. Good. And then there's the example of like what it might look like. Okay. So any questions about this assignment? Do you feel like you can do this?
I think so.
Was that a sigh?
I feel like
A sigh of confidence?
I think I need to study up on what my part is, my standard.
Your standard. Okay. Good. Another comment. Do you know when my office hours are?
Tuesday, the 7th.
Tuesday from 1 to 3, because I am going to eat lunch between 12 and 1. That's my plan. Between 1 and 3. And then Friday, 8 to 9. So if you want to come talk about any of these things, then you can come to my office hours and I can talk to you. Okay, good. Okay, we're good with assessment, or formative assessment here? Feeling pretty okay? The next tool that I'm going to give you is designed to help you with this task, especially the three-dimensional part of it. It's this big, gigantic packet. Yay! Remember how you got the bookmarks? And they were, thank you for passing these out every time. Remember how you got the bookmarks and they were from a place called STEM Teaching Tools? Yes? So STEM Teaching Tools is a website. And on the website, they have these documents that are called STEM Teaching Tools. The purpose of this website is twofold. One is to support the idea of three-dimensional science instruction, and two is to promote equity. So attending to cultural differences and providing opportunities for all of your students to participate and be successful. So I've given you copies of 3 of the STEM teaching tools, number 26, number 30, and number 41. Okay, so number 26 is about how do we design assessments in general. Okay, and on the back, under the recommended actions you can take, it has the sort of 6 steps. It's the very front page, the back of the front page. See how it says number 26 up here? And then we're looking down here.
Okay.
Okay. So number 1, identify specific learning goals. We know how to do that. Don't you agree? Okay, number 2, brainstorm assessment scenarios that involve phenomena that clearly foreground the identified learning goals. Prioritize and select one scenario that best fits the criteria listed above. This is thinking about a phenomenon that would drive an assessment. So like, this is like how the other day, for example, I gave you the picture of the flask with copper and aluminum. And that was like, that's like a scientific phenomenon, right? And so the assessment was based on that. Okay? Prioritize phenomena that allow students from non-dominant communities to fully engage. So especially if you have like English language learners, giving them like a big description of an experiment or something might not be like the best way to assess because it'll be very challenging for them. It should involve a compelling phenomenon. And it should be quickly understandable and lend itself to a broad range of science and engineering practices. Number 4, the task formats. The task formats are what are in number 30 and 41. So we'll look at those in a minute, okay? Task formats provide detailed guidance on how to design components of the assessment. So you identify practices that relate to the scenario and use the task formats to craft assessment components. And then you can write a hypothetical student response for like no understanding, a little understanding, a lot of understanding, like maybe 3 different things, and then share them with colleagues for feedback. Yes? Okay, now let's look at number 30. This is about integrating science practices into the assessment tasks. So, it has these little boxes that you're going to see on the next pages, and it'll say like, this is what you're giving to students, and like then indented a little, it says this is what you ask the students to do. Yes? Okay, so then we have, for example, the first one will be about asking questions. So asking questions is one of the science and engineering practices. Yes? Okay. And then, for example, one thing that we could do is present the students with a scenario that describes a phenomenon, and then ask students to select from a list of questions to identify which ones can be investigated about that phenomenon. Like, what are reasonable questions, right? Present students with a scenario that describes a phenomenon, and then ask students to ask questions based on their observations, or ask students to formulate scientific questions to investigate that phenomenon. Does that make sense? Okay, so these are kind of like a little abstract.
Are these
What's the purpose of
ideas?
talking about this?
Yeah.
Because you guys are designing a formative assessment, and I said your formative assessment had to be at least 2-dimensional.
So this is helping us brainstorm ideas.
Because you might be like, okay, the science practice I'm using is analyzing data. So then you turn in here and you find analyzing data. It's right here on page 9.
So this helps us know what kind of questions to ask. That would
These
help
are the
them-
kinds of questions that will require students to analyze data. Are you with me here? Okay, nobody understands anything when I like just start talking. I was like, how come everyone is like not understanding here? Okay, does that make sense?
So this
So-
is a resource.
So this is a resource. If you're thinking, what science or engineering practice am I using, you can like flip to that one, and then it'll give you examples of how you can do that. So it's helping you. And then number 41 does the same thing, but it's for the cross-cutting concept. So like, let's say your cross-cutting concept is structure and function. Then you like open this up, and you're like, okay, where do I find structure and function? It's at the end, because it always is when you're looking for it. On the page 10. Are you with me here?
Yeah.
Okay, and it does the same kind of thing. So we present students with observational data, and then we say what structures are present in this thing. What function does each structure have? How do you think each structure behaves? Right, so these are like examples of types of questions you could ask that target that cross-cutting concept.
Those be like things if you were giving like a written quiz, you could just like put those questions on your quiz in the comments where you're in.
It likes to say phenomenon and like this thing, like where do we get that?
What's the phenomenon?
Yeah.
So you have to think about that the phenomena are based in the core ideas.
Right.
So like if you're talking about macromolecules, maybe the phenomenon that you might talk about is how DNA is double-stranded, right? And the 2 strands are held together with hydrogen bonds. Do you know what I'm talking about?
It's the phosphate groups that will hold DNA together?
Phosphate groups are along the chain. This is phosphate group, base, phosphate group, base, phosphate group, base. The bases stick out, into the middle, and then they hydrogen bond with each other. So phosphates hold together this single strand of DNA,
Right.
but the double strand of DNA is held together
Okay.
by the hydrogen bonds. Does that make sense?
Okay, so that's just like one example.
That's an
That would be
example of a
phenomenon.
phenomenon.
Okay.
Yeah, other examples of phenomena are things like demonstrations, or like something, you could watch a video that like shows something happening.
Okay.
It could be, a phenomenon could be something like data. So you could have like data table or graphs or something that they have to then, interpret. But you have to give them something to work with.
Right.
The idea is you're giving them some kind of scientific thing to work with.
Okay, even
Yeah.
like an equation to look at. Maybe, I don't know, just.
I don't feel like
depends on
an equation
everybody.
is a phenomenon.
Maybe not, sorry, not equation, a chemical reaction.
Yeah, a chemical reaction that they can
That's right.
observe or something like that, yeah.
Okay.
Mhm. Okay. This is what I would like to do with these. We're going to, what should we do? I had a plan for what I wanted to do, and today my brain is just like failing.
Same.
Do you feel that way? Okay, that's sad. Okay, let's look at the science practices, and let's see if we can, there's only 8 of them, so we'll divvy them up among people, but there's a couple of engineering ones. There's 2 that are engineering. Let me find them. This one, designing solutions.
Define your problem.
Designing solutions and defining problems. You can have both of those. Okay. You will have asking questions.
Wait, what page is it?
Starting on page 2, all these like,
Yeah. You're gonna have asking questions. You have defining problems and designing solutions, both engineering. They're orange. Turn the page.
So I only have asking questions.
For right now, you're gonna use whatever you want on your homework. You're gonna have developing and using models. You're gonna have planning and carrying out investigations.
And obviously, that's what you do.
Yes. You're gonna have using mathematics and computational thinking. Yours is really long, Evan. Okay, she's got that one.
No, that's my page.
You get
So what
arguments and evidence,
developing.
obtaining, evaluating, and communicating information. I guess you get an engineering one. Did I skip one?
yeah. Did you skip the constructing explanations and designing solutions?
Oh, they're not separate. Yeah. Okay, you don't have constructing explanations and designing solutions. You
I
just have.
I don't have designing solutions.
Is that the second page or the last page? Where's constructing explanations?
There's defining problems, and then if there's
Who
another.
has constructing explanations? Anyone? You get constructing explanations. Okay.
Communicating.
Okay. What I want you to do is I want you to read through all of the task formats. I'm going to give you about 10 minutes to work on this, and I want you to come up with a single prompt based on these guys that you would use in chemistry. So think about it in the context of the standards that you have or any chemical concept that you want. I'm going to give you about 10 minutes to read them all. You just have to make one prompt. And then we're going to share them with the class. Yes?
So like, what kind of a prompt, like an essay question? kind of?
All of these things are like the examples of what you can do. So you're supposed to do like one of these things. Some of these are designed, so for example, this first one says, you give them a scenario and then you ask them to select from a list of questions to identify which can be investigated. That could be a multiple choice question. Do you see what I'm saying? So you could do that too. Others are designed to be more open as